are 30 people. There are 30 people in a class. 15 are in math, 17 are in English, 3 are in neither. Remember, I told you that if I give you both separately and an either and a total, you can figure out the and. So if I go 15, 17, and 3, I get. But there are 30 in the class. So how many are in both? 5. So we go draw that. Math, English. 5. This is going to have
10.
This is going to have
12.
This is going to have 3. So we want being in math or English. So it'd be 27 out of 30, which can reduce to, you can take a 3 out of both, so 9 out of 10. Okay. Being in math and English. So it'd be 5 out of 30. And why am I dividing it? When in the last unit I would have just wrote 5. Yes.
Do we have to do the percent or?
Didn't say. You were supposed to answer my question. I was like so proud of you for a second.
It's because you need a probability.
Yeah! It says probability. You only have to do percent if it says percentage.
Okay.
But if you gave it to me as a percent or a decimal as a fraction, because I didn't ask for anything in particular, Cody, I'd have to accept them all.
Okay.
So 5 out of 30 reduces to 1 out of 6. Being in math only.
Wait, how'd that reduce to 1 out of 6?
Take a 5 out of both.
Oh, wait, why did I put 4?
I don't know. Okay.
I just put an idiot for that.
Okay. 10 out of
30.
30 is a third.
1/3.
Okay, and then odds. Odds in favor. When it says favor, whatever comes after it comes first. So odds in favor of math comes first. Then the complement comes second. So how many are in math, the math circle? 15. How many are not in math?
15.
So this is a direct correlation, 1 to 1.
You have to reduce those also?
Yep.
Why?
Because.
Even if it doesn't ask for it?
Yep. Always. Fractions are always reduced, odds are always reduced. Not enough.
If you start with fractions and then reduce it afterwards, so you do like the odds, you got it down to 1/2 and then you do the odds.
Did you get 1 to 1 in the end?
Yeah.
Yeah. You just reduced and then made it be?
Yeah.
Determine the odds against being in English. So odds against English. English comes second, not English first. How many are in English? 17. And then 13, and that doesn't reduce. This one is different than the previous one because I actually give you probabilities, correct? And probabilities in a Venn diagram should add to what? 1. So people at a grocery store are surveyed on whether they ski or skate. They determined the probability of skating is 0.4, the probability of skiing is 0.65, the probability of doing neither is 0.05. What's the total if I give you probabilities for a bit? 1. So it's the same as the previous question, except for the total being 30, and then we add them up and subtract. This one we're going to add them up and subtract from 1. So I get 1.10. So how many are in both? 0.1. So I have skating. So I get 0.1 in the middle. How many are in skiing only? 0.3 for skating. Skiing? 0.55 and neither? 0.05. So the probability of skating or skiing is 0.95. You just add them up. The snowman. Probability of skating and skiing, 0.1. Probability of skating only, 0.3. Odds in favor, so whatever comes after comes first. Odds in favor of skating. So skating comes first. And not skating comes second. How many are skating? 0.4. Ski, and then not skating? 0.6. Which they could write it like that. Or you can go 0.4 divided by 0.6. Math, enter, do that. So 0.4 divided by 0.6. Because remember we can reduce odds just as we do fractions. 0.4 divided by 0.6. Math, enter. You should get 2/3, right? So that'd be the same as 2 to 3. You need to be able to do both, because the answer on the diploma could be 2 to 3, or the answer on my unit test could be 2 to 3, not 0.4 to 0.6. Number 3, determine the probability of the following. Determine if they are mutually exclusive or not from a deck of cards. Mutually exclusive means no overlap. So I am taking out one card. What's the probability that this card is a king or a 3? So when it's or, we go to either of these two formulas. Mutually exclusive meaning no overlap. Not mutually exclusive meaning not overlap. These two formulas. Put it in our notes. So, are there kings that are 3s?
No.
No, so it's mutually exclusive. So I just add their two probabilities up. So I do probability of king plus the probability of a 3, which is 4 out of 52 plus 4 out of 52, which is 8 out of 52, which reduces to, I can take a 4 out of both, so 2 out of 13. Queen or a heart. So that's the probability of a queen or a heart. Once again, I have to go to these formulas with the ors. Are there any queens that are hearts and hearts that are queens?
Yes.
There's one, the queen of hearts, right? So I have to add up the probability of a queen plus the probability of a heart and subtract off the queen of hearts, because I've counted it twice. So the probability of queen plus the probability of a heart minus the probability of a queen and a heart. So there are 4 out of 52 queens plus 13 out of 52 hearts minus 1 out of 52, which equals 16 out of 52. Take 4 out of both, get 4 out of 13. The second half we're going to go over tomorrow, so do not lose it. Open up your rational notes, please. So we are here. So we did these yesterday as your homework. It said to determine the non-permissible values. But what I said before you do non-permissible values is you first reduce the numerator and reduce the denominator by Gcf or difference of squares. So on the top, on A, I could take out a 2. And then I'm left with x minus 2. And then remember I told you, put that 2 in brackets as well. So I always start with these in brackets just so because they're attached by a plus or minus sign. Okay? The second one, what? It doesn't, but we're going to start simplifying right away, so I'm practicing. Yeah. So we're going to simplify the denominator. We can take out a -2, minus 2. And we take a -2 out of -2x. I'm left with x. Take a -2 out of -4. It's -4 divided by -2. It's plus 2. Now, if they only ask for non-permissible values, do I actually have to Gcf or difference of squares the numerator if all I'm asking for is non-permissible values? No, I don't have to. But we're practicing because we're going to start simplifying today. Okay, so we're going to need to do this anyway, so we're going to practice it anyway. So the only thing if it asks for non-permissible values, the only thing I care about is the denominator. So once I've reduced the denominator, I take each of the things that are in brackets and I set them not equal to 0. So my NPVs, can I write NPVs on a unit test or on a diploma? Nope. NPVs is short form. You can write NPVs in your notes, right? Because you know it stands for non-permissible values. But on a unit test, if it says determine the non-permissible values, you'll write the non-permissible values are and write what they are. You're not going to give any short form. There's no short form on unit tests or on the diplomas. Short forms will take part marks off. Okay? I have no idea what you had. So, I'm going to take -2, and I'm going to set it not equal to 0. And that's true. It's a true statement, but it doesn't give me a non-permissible value because there's no variable. Correct? So that's, yay, that's good, but it's not a non-permissible value. And then we have x plus 2 cannot equal 0. We subtract our 2 over we get x cannot equal negative 2. So my non-permissible value, which they can also call a restriction, is x cannot equal negative 2. Okay? They can call it a restriction as well. Yeah. Yeah. Okay, the next one. Can I do any, I put them in brackets right off the hop. Can I do anything to that negative 5 on the top? Nope. So it stays the same. What about the bottom? It's a difference of squares, right? So if I square root the a squared, I get an a. I square root the 81, I get a 9. And I have a subtraction sign. If I have an addition sign, can I do anything? Nope, it just stays the same. So I'm going to get a plus 9, a minus 9. And then to do my non-permissible values or my NPVs, which I can write because these are my notes, I can go a plus 9 cannot equal 0, a minus 9 cannot equal 0. Subtract 9 to solve for a. A cannot equal negative 9. Add 9. A cannot equal 9. So you could write it as a cannot equal negative 9 and 9. You can write it like that. It's totally fine. Or you can write it as a cannot equal plus or minus 9. Like that. The plus or minus 9 is how they're going to write it on the diploma. And on my unit test, you'll see it as plus or minus 9 like that. Okay? C. First thing I do, go away. Stop it. Ah, there we go. Okay. So for C, first thing I'm going to do is bracket both of them. Could I bracket the 12 and the P separately, technically? Are they attached by plus or minus signs? Nope, so I can put them separate. So I'm going to go 12 and P in their own brackets. Because unless they're attached by plus or minus signs, or the 12P is attached to something with a plus or minus sign, they can go in their own brackets. On the bottom, I can take out a P. 4P squared divided by P is 4P. Minus P divided by P is a 1. And the P is in its own brackets. So I can write NPVs because it's my notes, so I can short form, but on a test I can't. I take each bracket said equal to 0, or not equal to 0, sorry. P cannot equal 0, 4P minus 1 cannot equal 0. This one is done. So that's one of them. It's already solved. The other one I have to get P by itself, so I'm going to add 1. 4P cannot equal 1. Divide by 4. P cannot equal a quarter. So my NPVs are P cannot equal 0 and a quarter. So it's 0 because it's actually P cannot equal 0, we agree? But this previous example here for A, this was negative 2 can't equal 0. Did that give me an NPV of 0? No, it's just a true statement. So if it's a number can't equal a number, the only NPV is the one with a variable, correct? So I got x cannot equal negative 2. People will tell me 0 for this one. They'll say negative 2 and 0 when they give me the NPVs. This one didn't have a variable. It doesn't create an NPV. This one, however, I get P cannot equal 0. Because it's P cannot equal 0. It's a variable. So I would state the 0 for here, but not for that one up top because it was negative 2 and 0. There was no variable. This last one, x minus 2 stays x minus 2. The bottom I can take a 2 out. It's x squared plus 4. So I have 2 cannot equal 0, and I have x squared plus 4 cannot equal 0. Why can't I split this into x plus 2, x minus 2? It's an addition of squares, it's not a difference. So you can't do anything to it, it just stays that way. This one is true, but it doesn't give me an NPV, correct? This one I'd have to subtract my 4 over. So I'm going to go x squared equals negative 4. And then I'm going to square root it. And when I take the square root, I take the plus or minus. So I have x cannot equal plus or minus the square root of negative 4. Can I take the square root of a negative?
No.
Nope. So no non-permissible
Why'd
value.
you square root it?
Alright?
Why'd you square root it?
Get rid of the squared off the x.
Why?
Because you want to get x by itself.
But x is by itself in the fraction, you gotta get that by itself for that NPV.
What?
Because in the fraction, it's x squared, so why would you just keep it x squared and just put -2? And that would make it 0.
Because then you have x squared equals.
Because the x squared is what it is, not x in the fraction.
Yeah, put a -2 in there. What's -2 squared?
Yeah.
It's 4. What's 4 plus 4? Not 0. There's nothing you can fill into an addition of squares that's ever going to make this bracket be 0.
-2 squared plus 4 is 0.
You're typing it into your calculator like this. Yeah, that's not this. That's negative. That's if it's this. That's not at all what this is. If you want to type into your calculator, you have to go like this. -2 squared. And -2 squared is 4. It's -2 times -2. Anything to an even exponent will turn positive, right? So you have to watch when you type into your calculator, because when you're doing this, your calculator is doing this. Not this, which it needs to do. So if you want to square a -2 in your calculator, you have to go square. If you don't have the brackets, it's going to tell you it's negative every time, and it's not, because anything squared will become positive. Because -2 squared means -2 times -2, which is positive 4. So any negative raised to an even exponent turns positive. So if it's to a 2 or a 4 or a 6 or an 8 or a 10, you get a positive. So whenever you actually have an addition of squares, you don't get a non-permissible value. Because there's nothing that I can do here to get a negative, to get that 4 to go away, right? Because no matter what I put in here and I square it, it's going to become positive. Anything positive plus 4 will never turn into a 0. So addition of squares never gives NPVs. You might want to write that yourself down. We're going to skip over equivalence for now. And we're going to move on. We're going to come back to equivalence because when I taught them in order like this, I lose people. So we're going to go to example 5 for now. We will come back to equivalence later. Example 5. In each case, write a rational expression with the given variable and non-permissible value. So you're making your own rational. So I have a variable that's x, and I want a non-permissible value that is at 3. So I want x cannot equal 3 as my non-permissible value. So I have to work backwards to get what it was in the rational. So how do I get it backwards? I have to get it back equal to 0. So how do I move this 3 over here? I'm going to subtract it. I'm going to bring it over. So I'm going to get x minus 3 cannot equal 0. So what would actually be my rational in the denominator? X minus 3. So I know for a fact I have to have that. Does it say anything else? Can I make the numerator whatever the heck I wanted it to be?
Yes.
Yeah, I could go like x minus 4. I could go 7. I could go -2. I could go immature. I could go 9. I could go -9. I could put an x squared plus 4. I could put a difference of squares on the top. It wouldn't matter. But the only thing I absolutely have to have is a variable of x. And I have to have something in my numerator. You guys are going to do B and C. Try them out. So we have a variable that's a. So if you use x, you're right off the wrong eye, right off the hop. Our non-permissible values are a cannot equal 0 and a cannot equal 4. This one I already have back to 0, right? So in my rational, I'm going to have an a on the bottom in brackets because that's how I'm going to get my can't equal to 0. Okay? This other one I have to work backwards here. It's a positive 4, so I'm going to have to subtract 4. So I get a minus 4 cannot equal 0. So that'll be my other one on the bottom. And then on the top, I can put whatever I want. I'm going to put a plus 3. I could have put a 6, a 2, I could put a squared minus 73. It doesn't matter, right? This one is a little bit trickier, but we're still following the same thing. We have a variable that's p. Our non-permissible value is a third. What people will do is they'll just say p minus 1/3, which is not actually the answer. You have to remember when it's a third, it used to be something that you have to do 2 steps to get to. So the first thing we have to do is actually move the 3. We do it in a 2-part step when it's a fraction. How do I move the 3? It's a division of 3. So I'm going to multiply by 3. So now I have 3p cannot equal 1. And then I move the 1 over by subtracting it. 3p minus 1 cannot equal 0. So that's going to be my denominator. And my numerator could be just p if I wanted it to be, or p squared. Or 6. The last one, my variable is m, and my non-permissible value is -8. So I'm going to have m cannot equal -8. To move it backwards, I'm going to add 8. So I get m plus 8 cannot equal 0. Now that's going to be my denominator. And in my numerator, I'm going to go m squared minus 9. I can do whatever I want, right? You could have just put -1. You could just put a 1, actually. Yeah?
Can you put p minus 1/3?
No,
Why?
because it wasn't p minus 1/3. It was 3p minus 1.
How do you know that?
Because it's never a fraction like that. No,
Why?
because it's an integral. If ever you've gotten a half or something like that, I had 2x minus 1 in your denominator. You'll never have x plus a half in your denominator. It's not irrational. So you have to do it in the 2 steps to bring it back. Multiply and then subtract. Okay, we're going to flip over. Yeah. Yeah. Simplifying. So we've technically actually done all the steps up to simplifying, just not including actually physically canceling them off. That's it. So today, all we're going to do is if something matches, we're going to cross it off. That's it. So yesterday, we prepared ourselves for this without even knowing we were preparing it.
Try not to do that.
Not to do what?
You said you were like canceling stuff off and you didn't work out.
No. Canceling stuff off like this. And they go 6 over 7. I get that. It's not true at all. They just start crossing random things off. So I said, don't do that.
That's it.
So we don't want to go randomly and say like, ooh, there's an A here, and an A here, an A here, and an A here, and some 1s, and this becomes 6 over 7. That's not good. I'm going to get that every single time. Super wrong. Okay? So we don't just go randomly canceling. So our first steps are to always, when we're simplifying, whether it's multiplying, dividing, adding, subtracting, just plain old simplifying like this, we're going to go to our numerator, the Gcf difference of squares it, go to our denominator, Gcf difference of squares it. Every single time, very first step. Is there anything I can do to, so I'm going to put this in brackets, is there anything I can do to 12x squared? No, it's a monomial. What I can do is I can write it as 12 in a bracket and x squared in a bracket. The bottom, I have a 2 and an x. Can I do anything to that? Just write it in separate brackets, right? And I can write it in separate brackets because it's multiplied. If it was an addition and subtraction, those babies would be stuck together and you'd have to put a bracket around both of them. But these are multiplied, so I can go 2 and an x. Now, some people get like super excited and see they can cross stuff off at this point. You must state, and I'm going to repeat this twice, you must state NPVs, or non-permissible values, restrictions, before you cancel. So I'm going to say it again. You must state non-permissible values before you cancel. If you state them after, they will have that answer there and it's wrong. Why do you have to state them before? Let's understand why so we're not just sheerly memorizing. The reason why you have to state non-permissible values before you cancel is they were a non-permissible value at the beginning of the question, right? So they still have to be stated. Some people will cross them off and they'll be like, well, now they're gone. That's great, they're gone now, but they were there at the beginning, right? Non-permissible values are values that would make your denominator 0. So if you put them into your original, they would make your denominator 0. It doesn't matter that you cross them off and now they wouldn't. They still would at the beginning. So non-permissible values, restrictions, must be stated before you cancel. Okay? So I'm going to do my non-permissible values. So I do Gcf difference of squares first, then I do non-permissible values next, then I cancel. Canceling is my very last step. So let's do my non-permissible values like we were doing before. So I'm going to go 2 cannot equal 0. Is that an NPV? Nope. I'm going to go x cannot equal 0. Well, that one's done already. So my restriction, or my NPV, is x cannot equal 0. And I'll show you how you don't even have to write it out. You don't have to write out the word non-permissible value because you'll just write it at the very end of your answer. Okay? So I just box it over there. I hold it. That's my only non-permissible value I have. Do I care what the numerator has for my non-permissible values? Nope. Okay. Now I can go to my brackets, and if they are monomials, which means they don't have plus or minus signs, I can expand it. I'm going to expand it so you don't mess these up. So I could rewrite this as 12 times x, couldn't I? Over 2 times x. Because x squared is just x times x. Now I can do 1 for 1. So I can take 1x off for this 1x. That's it. I stated my non-permissible values before. If I didn't, I would say there are none. So we'll state before we cancel. And then when there's just a number, you can see, can I take something out of both of these? A 2. 2 divided by 2, I'm left with a 1. 12 divided by 2, I'm left with a 6. So in the end, my answer, and all these little these little slashes, do you know what those little slashes are? They're ones. Whenever you slash and simplify, those are just ones. So like this is like a slanted one right here. These are all just ones. When you slash them off, that's what you're actually doing, is you're drawing ones. So this is 6 times 1 times x times 1, which is 6x in the numerator, right? Over 1 times 1 times 1, which is a 1. If I have a 1 in my denominator, and that's it, do I have to write the 1 out? If there's a 1 in the denominator? No. If there's a 1 in the numerator, do I? Yes. Because every number, if it doesn't have a denominator, its denominator is 1. Like the number 6, I could write as 6 over 1 if I wanted to. Right, Cody? So it's going to equal 6x. We don't have to write the 1. And then you don't have to write non-permissible values equal. You can just go behind it with a semicolon and write your non-permissible value. X cannot equal 0. Covered it all. Here you go. Put it in a box. So you don't have to write the word non-permissible value. If you just follow behind your simplification and say x can't equal 0, you're stating it. We don't have to spell it right or anything. Okay? B. B is already simplified. Right? Is there anything I can do to a plus 1, a minus 6, a minus 7, a plus 1? They're all in little simplified forms, right? So there's nothing I can do to them. But before I cancel anything off, I need to state NPVs. So I'm going to go a minus 7 cannot equal 0. A plus 1 cannot equal 0. For this one, I'm going to add 7 to both sides. I'm going to get a cannot equal 7. Here I'm going to subtract 1. A cannot equal negative 1. So I have a cannot equal 1 and comma 7. Box it so I remember to put it at the end of my question.
Should the 1 be minus 1?
Yeah.
Totally is. I don't know what you're talking about. It was there the whole time. It was just in like invisible form. All right. Now, remember it was 1 for 1, and the only thing that you could cancel off that wasn't 1 for 1 was when they were just numbers in a bracket. When they're just numbers in a bracket, we can divide out something that's the same, correct? But if it's variables, it's 1 for 1. It has to be its exact twin on the top as the exact twin on the bottom to cancel, okay? So are there any twins on the top and the bottom of this one?
Yes.
What?
A plus 1.
A plus 1. So this A plus 1 can cross off this A plus 1, and it can cross it off only because
Same.
they're identical, and I've stated non-permissible values already. Because I'm not allowed to cancel those off until I've stated my non-permissible values. If not, you're just going to tell me A can't equal 7. You'll be missing one non-permissible value. You'll pick the wrong multiple choice answer, and you'll be sad. Okay? So we always state our NPVs before we cancel. Now we have A minus 6, A minus 7. Can I cross the A's off on both of them? No. This is A minus 6. Unless it's complete twin, in brackets, this is on the bottom, it ain't canceling. A minus 7, it's twin on the top, not canceling, right? So can it be any prettier than this? No? Do you often want it to be? Yeah, so you start canceling A's off and give me 6 over 7? No, that's not good. Stop. Something too much. So we're going to get A minus 6 on the top. You can keep it in brackets or not in the answer. A minus 7. And behind it we follow with A cannot equal negative 1 comma 7. There's my answer. Cody, pick up your pencil. You too, Patchy.
I was just admiring your work up there.
I was admiring your not work down there.
I just got back.
I believe you.
You want to know something crazy? I was watching.
All right, C. So I go to the top, the numerator, and I say, what can I take out?
8y.
2.
Wait, hold on.
You can't cross off those 8 y's no matter how much you really want to, remember?
Oh,
Yeah. So what I would do is I would always bracket my numerator and bracket my denominator so that I don't go crossing off the 8 y's and give me a 2 on the unit test. And you're like, I would never. You often do.
wait, why did you put a 2 on that?
Because I'm going to take a 2 out.
Oh,
So remember our first step, bracket the top and the bottom. Our second step is to Gcf difference of squares, the numerators and denominators if we can. So I can take a 2 out, so I'm left with 4y, and people will put a bracket.
no.
No, heavens to Betsy's, we don't do that. What do we put?
1
Plus 1. Because when we take out a GCF out of 2 terms, we better still have 2 terms. Because if I distribute that back, do I get what I had before? Yep. But if I distribute it into the 4y, all I would have is 8y, which is not the same as what I had before, and I made it oopsie.
Would you bracket off the 4?
Nope.
Why?
Because the 4y is attached to the 1.
But I thought the 4 wasn't attached to the y.
That only happens when it's just them. Remember I told you once you hit a plus or a minus sign behind it, everything's attached.
Gotcha.
So if it was just a 4y, we could totally do it. But because the 4y is attached to the 1, they're attached. Yeah. Good. All right. Bottom has 8 and a y, so there's nothing attached to it. If it was an 8y plus 1, I'd have to put it in brackets. We agree? If it was an 8y minus 3, I'd have to put it in brackets. But because it's just an 8 and a y, it's a monomial, which means I can make it an 8 and a y in its own brackets. If it was attached to like a plus 2, though, I'd have brackets around the whole thing. I couldn't just put the 8 and the y in brackets. Now I go to do my NPVs. And I'm going to get 8 cannot equal 0, which isn't an NPV. It's just true. And then y cannot equal 0. It's already done for me. So that's my only non-permissible value. Then I look at the top and I say, I have a 4y plus 1. Do I have a 4y plus 1 in the denominator? Nope. That baby's staying. It better be in my answer because it doesn't have a twin on the bottom. Y. Do I have a y on the top? Nope. That's staying, right? The only thing that you can get away with not doing 1 for 1 is numbers that are in brackets by themselves. So there's 2 and the 8. Can I take anything out of it? Take out a 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So on the top I have a 1 times 4y plus 1. Do I need to write the 1? Nope. So I have 4y plus 1 on the top, and I can keep it in brackets if I want or not. It's fine. And then on the bottom I have a 4y in separate brackets, or I could write them without the brackets in the answer. And I have to remember to follow behind with y cannot equal 0. You guys are doing D and E and F for homework.